So hello guys and welcome back to my channel. So basically today we will be again solving some very good questions for JEE Advanced, and this will be the first question for today. And before I begin guys, some instructions. So basically I have been doing this 2 question series now, and each video would contain 2 questions, and I found out a lot of positive response from you guys. So I guess I would continue this for the next few videos, and in the meanwhile I will also try to bring in some JEE mains questions. Okay. And also a disclaimer before beginning, these questions which I am bringing in these videos are not mine, like I have not prepared them. These have been prepared by a group called Mathsplorers. I have attached their Telegram channel link in the description, so you guys can go there and check out their test series also. They have a test series also paid, so you can check that out. Obviously it's given in the description. Okay. Anyways, so this will be our first question guys for today, and let me tell you, this question is a very good question. Okay, so please try it out. I will wait for a few seconds and then I will start solving it. Okay guys, I guess now it's time for me to solve this. So basically we have to find out two things, P and Q, and after that we have to add them up and find the final solution. Okay, so for P, let's do this thing quickly. Okay guys, I will change the ink, just a minute. Yeah, so for the first part, it's logarithm of x based 2 is equals to your 5 times of sine 5 pi x. Okay, and x is belonging from your 0 to 32. So I guess it's well defined. Logarithm is also well defined, and sine function is also well defined in this interval. And now if we try to actually observe the nature of the curves, okay, because we have to find the number of solutions, so we need the number of intersections. So if you actually observe the nature of the curve, log x base 2 curve will go something like this, right? And actually 5 sine 5 pi x. So basically it's not normal sine x, it's sine 5 pi x. Okay, which means that actually if we have multiplied a factor here, the normal sine curve has, say, like whatever frequency the normal sine curve has, the frequency will increase. Okay, so it will go something like this, just an arbitrary idea. It will go maybe something like this. Okay, like pretty fast, I can't even show how. And also, like, I have, this is not very uniform. The peaks obviously will be uniform. Okay, they will intersect the logarithm curve at various points, that's obvious, and the peak will be your 5 times. Okay, it will be 5. I have not drawn it uniformly, I'm sorry, but I hope you can understand. So now to find out the number of points of intersection, I guess you have understood it's not possible from drawing the curve. So basically let's put in into knowledge some like formulas of functions that we have learned. So going back to our very old basic topic in functions, which is period of functions. So as you know that this is a composite function. Okay, so period of sine 5 pi x, if we can find that, it will be obviously same as your period of 5 sine pi x, because this factor can't change the period, this factor can. So basically our period of your normal sine x is 2 pi, and this is your factor 5 pi. So if you divide that, pi gets cancelled, so this is your 2 by 5. Okay, and now I guess you can understand that x is from 0 to 32, and obviously one thing also you can understand that this sine curve will obviously pass through 0 comma 0. Okay, so basically it passes through this point. So now if we want to actually find out the number of intersections, like you can understand that 32, 0 to 32 is x equal to 1 2 3, right? Say if we try to put, say if we put x equals to 1, okay, x equals to 0 actually gives us an intersection point. Like if we try to find out the points of intersection on this, x equal to 0 gives us 0. Okay, when we put x equals to 1, that is also an intersection, 2 is also an intersection, 3 4, actually all numbers are intersections. Okay, till 32. That's pretty cool. So basically all these numbers are being intersections, and maybe in middle also. We don't need to actually find that. What we will do is, basically we will apply a simple trick, because we know that the period is 2 by 5, right? So it is repeating every 2 by 5 intervals. So what we will do is 0 to 32, we need the points, right? We don't need integer points, we need the points from 0 to 32. So 30, like whatever integer points or decimal points, that doesn't matter. We have the period, we have the interval, and it's like if you want to find out the width of the interval, it's 32 minus 0, which is 32. So what I will do is I will simply take 32 and divide this by the period 2 by 5. So this becomes your 32 times 5 by 2. So 2 and 32 will cut as 16. So 16 5s is 80. Okay, now wait a minute. The thing is not over. Basically, 80 is not the final answer for P. 80 is for, like, how do I explain? This thing is sine curve, right? Maybe I don't know. I forgot the exact term for this. You call this, I guess, crest and trough. So 80 will be either for a crest or for a trough. If you have to add both, you have to multiply it with 2 because it's 2 cycles, right? Like one half and the other half. So this is for one half. We have to multiply with 2. So basically your P will actually come out to be 160. Okay. I hope this is understood. This is like very basic functional knowledge that we use. We directly divided the width of the interval with the period and got the number of this thing, your solutions. So yeah guys, I guess your this thing will be 160, which is equals to P. So that's it, and now I guess we can move on to solving this pretty difficult looking differential equation. It's not very difficult. I will show you how. Okay, so guys, I'm doing the second part, right? Like, I will give you a short introduction here. So basically, if you observe this equation, it's sine x square y plus 2x square y cos x square y dx plus of this thing dy equal to 0. You actually don't have to manipulate anything and bring any LD or something, okay? If you actually like group the terms, you will understand that something is hidden here. Basically what you do is you take this term and this term. You take these three in a bracket and you take this small dy to the right hand side. And now I will write that final expression below, changing the page. Okay, so this thing is your sine of x squared y plus of this is 2x squared y cosine x square y dx plus of your x cube cosine of x square y dy, and this thing is actually equals to minus dy. Now if you actually observe carefully this part, the left hand side, this thing is actually nothing but d of your x sine of x square y. You can cross check if you want. Like first you will take this as a you will take like differentiate this will be sine x square y plus of when you differentiate sine x square y, you are basically partial differentiating the equation. So once you have to take y constant, then x you have to differentiate with respect to, and after that you have to take x constant and then with respect to y you have to differentiate. So exactly you can verify and match. That is the thing which is given here. Okay, so what I can say is this thing is equals to your minus dy. That was the problem. This is nothing difficult, like just sheer observation that is needed. So if we integrate both sides, we will get your x of sine x square y, and let's bring this minus y to the left hand side, plus y equals to constant. Okay, so we had some information given that your y of 0 is equals to 1. So from there if you put, you will actually get c as 1. I hope it's pretty clear. So this thing, actually the equation becomes your x of sine x square y plus of y equal to 1. And now we were supposed to, I guess, find out y of alpha was given to be equal to 1, and I guess we had to find out alpha sine of alpha square or something like that. I will just check once. Yeah, we were supposed to find alpha sine of alpha square. Okay, so now if you basically observe this thing, if we put these values in our equation, we will get your alpha sine of alpha square to be equal to 0. Okay, and if you want to like elaborate this thing further, we actually needed this direct result only, but if you want to know for what alpha, then basically it's your alpha square to be any n pi. Okay, n belonging to whole numbers. So that's it, and I guess we will not need that part. We just needed the value of this thing, so it's 0. So basically your q comes out to be 0, and we were supposed to find out our p plus q, which is your 160 plus 0. So your final answer for the first question will be 160. I hope this question was good, guys. we are finally done with this question. So now I will move on to the second question for this video. So this question will be a second question, guys. So you can try this question out. I guess you can solve this. You can try it out. I will wait for a few seconds and then start on solving. Okay guys, I guess now it's time for me to solve. So basically what I am doing is I don't have any space on this page. I hope you have written this down. Please write this equation for your reference. And now I am changing the page. Okay, so guys, let's write down our equation, which was your f of x given to be 1 minus of 2x plus of integral 0 to x e power x minus t into f of t dt. This is what has been given to us. And now I guess there is nothing to do from here. So let's go on differentiating this by applying L'Hospital's rule. So it's f dash x equals to 1 is a constant, so gone, minus 2x is minus 2 plus of. And now for like differentiating this particular thing. Okay guys, just a minute, I guess I missed something out. Just a minute. Okay, I thought that I had missed something. Okay, there is nothing missing. So basically what we will do is we had a e power x minus t, right? So I would have done that here only. I'm writing this here. I can write this as your 1 minus 2x plus of e power x. I'm taking outside because it's nothing to do with this integral, and we will have integral 0 to x e power minus t f of t dt. Okay, and now we will be differentiating this thing. So if you observe, if when we keep this particular thing constant, e power x differentiation will give us e power x only. Okay, and e power x, when we keep constant and differentiate this particular thing, it will be your e power minus s minus x f of x. So basically, actually, if you evaluate that, it comes out to be the same thing, integral 0 to x e power x minus t into f of t dt. It comes out to be the same. Okay, so f dash x is equal to this thing, and now we actually can't sort of form any differential equation or something with this huge term here. So what shall we do? We shall like take this thing from here because it's present in the normal f of x. Okay, so if you actually like, I will write this with an arrow. If you see your integral 0 to x e power of x minus t into f of t dt, from the first given expression, it actually is equals to your f of x plus of 2x minus 1. So if we substitute that, this thing will actually become, I am writing f dash x as dy by dx. This will be equal to y plus of 2x minus 1. And if we rearrange, dy by dx minus y is equal to 2x minus 1. This one is a perfect differential equation, linear differential equation rather. So I guess now we are in a good position to solve this. So if we find out the integrating factor for this, it will be your e power minus 2x. Pretty obvious. Okay, and just a minute guys. Okay guys, I actually missed out something. Basically this thing, I forgot to write one term. Okay, so if when we differentiated this particular thing, actually one extra f of x will also arrive. Okay, actually I solved this thing and I saw this and it struck my mind that I had missed this. I'm sorry. So there will be one f of x already, and after that when we substitute this particular thing, it will actually become 2y. This thing is your minus 2y. Okay, I'm sorry. So now this will be your e power minus 2x, I hope. So we can write this thing as y e power minus 2x is equivalent to integral of, this thing will actually be 2x minus 3. Here also I made a mistake. This thing will be 2x minus 3 because minus 2 and minus 1. Okay, lots of mistakes, I apologize for that. So 2x minus 3 and your e power minus 2x dx. So this thing is basically what we have to integrate. And so you can obviously use by parts, but what I would prefer is, we had learned the tic-tac-toe method in our last videos, like I had taught you. And if you are new to my channel and you don't know, I will still show it down in a few seconds. So basically we take u and v. We take one part of this as e power minus 2x and the other part as 2x minus 3. Basically the u and v. Okay. And now whatever we take as v, this is v here, this is u here. So v will integrate that thing. This is minus of half e power minus 2x, and after that this will be half, sorry, 1 by 4 e power minus 2x, and u we know, u actually we will differentiate here. So 2, and after that this will be 0. After that we take arrows from the differentiated towards the integrated functions in a sort of ladder type manner like this. And so using this we will add and subtract these successively. Okay, like this will begin with plus and then it will be minus. If we had further steps it will be plus minus and so on. So if you actually do this thing you will get this expression to be your minus 2 times 2x minus 3, or maybe I will write down the final expression only, that would be better. So y e power of minus 2x, this would actually come out to be equals to minus of e power minus 2x times x minus 1 plus of c. Okay, so this is your final differential equation. And now I guess, okay, what I will do is I will multiply e power 2x on both sides. That is actually pretty to see. So 1 minus x this will become because of the minus, and this is your c times e power 2x. So this one is our final differential equation, guys, and now I will try to find out the constant. So basically constant we can find, you can apply two methods. Either you can like f of 0 equal to 0, that you can apply, or what you can do is like directly place, you can differentiate this thing, right? Like differentiating this expression is not a big deal. If you actually place this thing in your this equation you will find that it is coming something like, I guess, 1 equal to 1, okay, which is a universal truth. These expressions are called universal truth expressions. 1 equal to 1 is universal truth. So basically that means that maybe there will be many values of c which is satisfying this. So what you can do is you don't need this thing, so you can put c equal to 0 just like that, it will not harm anything. Okay, or you can also go for putting f of 0 equal to 0. I will just check and see. Or guys, just a minute, I don't think, no, don't put actually x equal to 0 directly, okay, because limits are tending, you can't exactly put them, I forgot. So better thing is actually you can differentiate this thing, this expression, and put this in this particular thing, and after that when you put you will get 1 equal to 1. I guess I had solved like that. So basically it's a universal truth, so basically it means that there can be many values of c satisfying this equation. So I guess I put c equal to 0 directly, not harm. Okay, so now I guess we can go on to the options. Okay guys, I actually found out something better interesting. Okay, like you can ask me the question, why can't we put c as 1 2 3 4? It can be multiple values, you can raise this question. So basically the safest method will be you can put that thing in here. Okay, I guess that will be the safest method. I was trying to find out smaller methods, but I guess we want distinctively, right, the solution. So you put that equation into actually this particular thing. I solved it right now, and actually you are getting c as 0. Okay, you're actually getting c as 0. You can put that thing we just found out, f of x or y, whatever you call it, into this equation and you will get c as 0. And c is very distinctively 1 minus x. Okay, so now if we try to evaluate these things, let's see, the curve y equal to f of x passes through 1 comma 2, so that's pretty false. Curve y equal to f of x passes through 2 comma minus 1. Okay, yes, it's true. Option B is one correct option. And in option C and D, I guess we have to do an integration because it's area of the region. The one part of a semicircle is given, not a part, like a semicircle is given, and this equation is a straight line. So we have to actually solve this thing. Okay, so I guess not a very big deal. I can actually solve it here only, no need to change a page. What I will do is I will directly write, like I don't think we have to draw graphs and anything, it will be directly your integral 0 to 1, because 1 minus x equal to 1 minus x square will, like, it's passing through the origin and 1 will be the only point. Okay, so root under of 1 minus of x square, and this thing is your minus of 1 minus x dx. So this thing will be your expression of integration. And now what you can do is, like, don't solve everything and anything, okay, because this is an area, and area we know some standard area, so don't go like blindly solving any integration you see. This is 1 minus x, y equal to 1 minus x is basically the area of a triangle that is crossing the this thing, your, like this. I will just draw a simple diagram. this thing, this is your 1, this is your 1 length, and this thing is your origin. So basically this part is the area of the triangle we want. So that is basically half into half into half, which is half. Half into 1 into 1, which is half. And this is a semicircle like this, whose radius is 1. This point is your 1 comma 0. So if you found out the entire circle's area, which is pi r square, so it would be pi. So basically this is a semicircle. So semicircle's area will be pi by 4. And actually this thing is not your, okay, I did something wrong. This is not 1 comma 0, this is 2 comma 0. Okay. So semicircle's area is pi by 4 and this thing is your half. Like this is how you do things quickly and without giving in too much time. Like you should keep your eyes open when doing such things. Okay, who will go on to integrate this huge expression when you know the standards? So this thing actually becomes pi minus 2 by 4, which is your option number C. So I guess this will be the correct answers for this question. Okay guys, actually there was some confusion here. I also was confused. Actually pi by 4 minus half is not coming from a semicircle. Okay, it's actually area of a sector. I will explain, don't worry, I will explain this thing. Basically all the confusion arrived from my diagram. Actually pretty messed up this. Our circle is like this. Okay, I hope you can see my pen. Our circle is like this and this thing is your sector. Actually this is the area that is being included. That is why I wrote a sector area is pi by 4, and I was all the whole time telling semicircle semicircle looking at this diagram. Okay, I'm sorry extremely. So these will be the final answers for this question, B and C, and that is actually, this term is actually your area for a sector. Okay, and that rest everything is okay. So that's it guys. I guess these will be the two questions for this video, and I will bring in such questions in my next videos also. So if you have liked these questions, please do like, share and subscribe to my channel, because it takes a lot of hard work to bring these in. And if you have any doubts, always write to me down in the comment section, and also any recommendations, you can obviously post them. So that's it for today guys. We will keep this up to here, and thanks for watching.